Ugh. Okay. So what we've got here, this is the Sonar Space Patrol. This is the whistle-controlled space toy made by Yonezawa. Now, I've done videos in the past on the Sonicon Rocket, Sonicon bus. They also made a car. And both this toy and the Sonicon, which was made, back then it was called Modern Toys, but it's Masudaya, they were all versions of the Golden Sonic, which was made by Tigrett Industries back in 1957, right here in the USA. And the Golden Sonic was very close to the original patent issued for the whistle-controlled toys. There's no transistors or tubes or anything in here. Everything is electromechanical. This one works the least responsibly. That's why I was blowing in 2 whistles at once. I don't have the original whistle for this toy, but I guessed it a couple of tones. It seems to be all 3 toys, this one being the Sonar Space Patrol, and then you've got the Sonicon toys, and then you've got the Golden Sonic. They all seem to be different frequencies that they operate on. They're not the same. They're using the same principle. They're all using a Helmholtz resonator, which is basically just a chamber, and it's tuned to a particular frequency. And then that chamber is going to make a couple of contacts, call it a vibration switch, open and close. Normally the contacts with no whistle are going to be closed, conducting. But as the proper frequency is recognized in that Helmholtz resonator chamber, it makes the contacts bounce, open and close. They run those contacts to a relay, and the relay does 2 things. One, it's a relay switch, so it's what's turning, doesn't turn the motor on and off, it reverses the direction. When there's no whistle, the motor's running in one direction, that'd be move forward. When it sees the whistle, then the motor reverses, and that makes the mechanism change the direction of the toy. All the toys have to give you an indication of which way they're going to go. This one does it, I think, in the best way. I really like this. Inside the dome, you've got a red and a green light and a divider, and that you can see that turn in there, so you know which way it's going to go when you quit blowing on the whistle. And the red light is an indicator that it's detecting the whistle. The other toys by Masudaya and by Tigrett Industries use a external antenna, rather a dish or something, and you look at where it's aiming. The problem with that is it's external, it's sticking there, and it's just waiting to be broken off and gotten lost, whereas this is all in one piece, which makes it better in that way. Back to the relay. The relay not only is changing the direction of the motor drive unit up front, but it's also a discriminator. It has to take the difference between a closed circuit and one that's vibrating and know when that means the relay is going to either stay closed. When there's no tone, those contacts are closed, so the relay is sucked down, it's in the closed position. When the contacts start bouncing in the Helmholtz resonator, then at some point the relay is just going to open up. It's not going to sit there and flutter, at least it's not supposed to. It should reach a point where it doesn't have enough DC voltage turning on and off, so it goes into an open state, and that's when it tells it to go into the turn mode. Now, the Golden Sonic by Tigrett Industries and the Sonicon toys, they all use a single pole double throw relay. That's the simplest relay, and what that really means is that if my finger is the contact that moves with the magnet, you have 2 fixed points that don't. So when there's no voltage applied, a spring is pulling this contact up, and when there's voltage applied, the magnet sucks it down. So no whistle, the Helmholtz resonator vibrator switch is touching So it's in the stuck down mode, and that should be the drive forward mode. When there is a vibration in the Helmholtz resonator enough to make that switch vibrate, at some point the relay is going to release its pole and swing to this open state. In order to reverse a motor with just one single pole double throw switch, you have to have a center tapped battery supply. The Golden Sonic by Tigrett Industries ran on 4 D cells, so they had 3 volts for the forward motion and they had 3 volts for the reverse motion. The Sonicon Rocket and bus car, they run on 2 D cells, so they're basically running the motor on 1.5 volts because they're splitting that power supply in the middle. What's different though about the Sonar Space Patrol, which is the toy we're talking about today, is it runs on 2 D cells, but they needed, or thought they needed, the full 3 volts for the motor and for the lights and all that. So they put in a double pole, double throw relay instead of a single. So there's 2 sets of those fingers that move up and down, and 2 sets of contacts up and above and below. And it's a much more expensive relay, but it's also harder when you're making a cheap one for a toy that's going to work right. And that's one of the biggest problems with this toy. And there's also a right way and a wrong way to wire up a double pole, double throw relay. The 2 fingers, the 2 contacts that move up and down, those 2 should go to the motor. The solid contacts that they bounce between should be connected to your battery. And they did it the other way around in this toy. And what that means, unfortunately, is with wear, if one of these contacts arcs, and they will arc and pit, and they cheaped out and didn't put a suppression capacitor in the circuit design either in this one. If one of them pits where one of them doesn't move, the relay turns on, let's say, and one of them stays stuck in the up position because nothing, or maybe the opposite, stays arced in the down position, and when the coil's turned off they should both bounce up, but one doesn't. Well, if one moves and one doesn't move, and we're only talking about moving about 0.5 millimeter, that means it's going to short out the relay, it's going to short out the power supply. It's going to further damage that relay, the contacts, the super thin, flexible little metal that they use to make these contacts go up and down, because it's such a sensitive relay, warp and get bent. And that was damaged in this one. What else? In this one they're using a plastic Helmholtz resonator, a chamber in the back, and a plastic diaphragm on the top, and then the little wiper that touches the top of the diaphragm, which is your vibration switch. In the Sonicon ones, buses and cars, the resonator is metal, and even the diaphragm on top is metal. And the Golden Sonic does the whole design a little bit differently because it followed the patent closer, but it can be plastic and still work better. I'm moving you guys over where you can see the computer screen, I'm hoping. Let's get over here, let's get that light turned off. So here's what the box for this Sonar Space Patrol looked like. This is an image I pulled off Alpha Drone. I'm going to be showing you some images here that basically just came off the internet. Can I do the forward and backward? Well, let's find out. This is the drive wheel mechanism. This big blue thing, this is the motor. Is your gear reductions. You're going to have one wheel that drives and one wheel that spins free. And the wheel that spins free, this is a ratchet. They're actually using the treads in the tire to form a ratchet. So if the wheel turned this way, the ratchet would lift and it would click by. But if the wheel tried to turn back that way, then the ratchet's going to dig into the wheel and lock it up. And they need to do that so that this whole mechanism can either drive the thing forward or spin on its axis. There's another ratchet that this whole mechanism, here's another view of the gear drive and the backside of the ratchet. That whole mechanism you were just looking at goes up in here and fits across here with a crossbar. This big gear is a ratchet, so that when it's driving, the one wheel is driving would normally tend to just make the whole thing spin, but if it's driving forward, then the ratchet locks up. If you reverse it, where the other wheel locks and then this one goes, then the whole thing can spin in place. So that's kind of how they get that. Now this is the top of their Helmholtz resonator that's inside this toy, and here's a clear plastic top. This piece of copper or brass, I guess it's probably brass, super paper thin, very flexible, because I didn't want to dampen any of this down. What's going to go across the top here is the vibration switch. Here's rubber grommets that isolate this whole Helmholtz resonator. This is the chamber. It's open in the bottom. And this, not only there are rubber grommets here, but there's also rubber grommets between this frame and the frame of the toy. And I had to go through and replace all those grommets because being, 60 to 70 years old, the old original ones were rock hard. This piece here, as I say, goes on top of this Helmholtz resonator. We're looking at it from the inside. That little piece there where I've started to clean the end is going to make a contact there. So normally gravity will drop that down, that finger down, and it'll rest on it and that'll close a circuit. The idea is when the proper frequency is heard, the whistle, then this vibrates and this will chatter, and eventually that'll make the relay open up. And here it is with the top piece installed. This is the original double pole, double throw relay that's used in this toy. This is a piece of rubber foam that I'm thinking about trying inside the frame to help isolate some of the motor noise from getting back into the Helmholtz thing and making it harder for it to hear the whistle over all the other motor and ratcheting noise. So here you can kind of see the makeup of the whole thing. Another problem in this design is when the motor turns on to go forward, that lurch will cause the little finger to lurch as well, the vibration switch, and then that's the same as it hearing a whistle, so then it kind of wants to stop and turn, or even if it just stops for a second, that causes another vibration, and then when it's done stopping, it tries to go forward, and that causes another vibration. So I ended up stacking a few diodes in here to basically run the motor when it's going in a forward, moving in a direction, to about 1.5 volts thereabouts. But when it goes into the turn mode, I go ahead and let it have the full 3 volts. Because the more that shakes and shakes that, the better it'll want to stay in the turn mode. The better it'll work that way. It's the other side, the on-off switch, the 2 D cells stack vertically. This gray box is what I had to add to salvage the double pole, double throw relay. Out of all the contacts that were in there, there was only one set that were working reliably. So I'm using that one set because I still need that relay in there as a discriminator to know the difference. But I'm going to have and letting that one contact part that's left drive a solid state H bridge to run the motor. So basically this is doing the work of reversing the motor and powering it rather than the contacts in here. The contacts in this relay are just turning this thing on and off. But it was about the only way to salvage that. So let's see, was there anything else on there? No, let's, here's some images I found online. This is inside the original Golden Sonic. The top is off. This big red tank thing, that's the Helmholtz resonator. These 2 wires tuck in these holes and they come up to 2 contacts right here and here. And this plate, which fits loosely on 2 holes in the back just to hold it in place, has conductive metal here in the front. So normally when it's not hearing a tone, though, this piece of metal hits those 2 conductors and closes the switch. And here's the very simple single pole double throw relay. And there's 6 D cells, 2 stacked end on end and here. So when the tone is detected inside this resonator, it makes this whole flap jump up and down and break and open the contact, and that's what controls that. I think I've got a lot more images here. Let's there's kind of a front view. This is one of the ones where you'd have the big tall antenna on top so you could tell which direction you were going to be going. But there's also a big window around there so you can actually kind of see the bump and go drive. And there were images on it. Here's a picture of their gear drive, and you'll notice they have tires with tread for the ratchet for the same reason. Comes with kind of a display. This big round ball thing here, I may have more close-ups of that. Let's look. That's the whistle that came with it. Now we're looking down the top. We can see the single pole double throw relay there. You have to have a commutator set up in order to get power down to the motor because it can rotate. There's some ratcheting gears here to lock it, and then there would be the ratcheting gears on the wheel. We've seen that image. There's one with the antenna on so you can see what it looks like. Here's a bigger picture of the big whistle. It's a very unique design on that. Back in 1957 when the Golden Sonic came out, it was almost a $20 toy. In 1957, 20 bucks would have been a very expensive toy. So I don't imagine too many kids could afford it except for the wealthy ones. I don't know if there's anything else here worth looking at. We're looking in the battery box where you stack the batteries in. There's a flat plate that goes in there and that rotates over to lock and hold the plate in. Advertisements. Okay, what else have I got here? I think, what did we already look at? Well, here's the Radicon bus, for example. I've done videos. I'll put links down below to the Radicons. I've also done a DIY where you can build your own tone detector circuit. And I've also done 3D printed versions of robots that move where I've used the Helmholtz detector but replaced the relay with electronic circuits. Let's see. There's a picture of the Sonicon Rocket, for example. And like I say, I've done a video on this one. And it has a more conventional looking type whistle, more like this is one that I was using earlier. And just a bottom view of it where the sound can go in to hit to the detector, and you can see where the two cells are and how it was boxed in the antenna and everything. Okay, I think that's about it. Here's another toy. I can't remember what this one was called, but it was another company that did a sonic control. As you can tell, the little kids blowing on the whistle. Since I don't know the vintage and age, this very well may not be a Helmholtz. It might be something from the late 60s or 70s, but it does kind of have that 50s, 60s look, so it might still be a Helmholtz. I really don't know much about that. I just found that image online and found it very interesting. Yeah, I think that's about it. Do I have anything else I wanted to talk about? I don't think so. I think we've covered it. Let's drop down here. So the resonator did seem to be more in line with a G note, but sometimes an F would trigger it. I didn't want to spend too much time reinventing the whistle for it because maybe the guy that sent me this for repair, maybe they've got the whistle and just didn't send it. I don't know. But I made a couple of different whistles to produce different tones. Louder is better. So even though this one I believe is not the right frequency, it triggers it because I think it's louder. This one you can see is much lower in tone. I think this is closer to the correct resonant frequency that's inside the toy. So let's turn it on and get it where we can see the lights. And let's try this whistle. So you see, when I can get fairly close to the toy, because I'm only an arm length away, it works very reliably. By the time I set it down on the floor, and now I'm 5 feet or more away from it, not so reliable. Let's try the one that was higher pitched to it with it too. You can see even the higher pitch one does it. But like I say, I'm real close to it here. I'm maybe 2 feet away. So makes a big difference once you're down on the floor. I guess if you were a kid, you would lay down on the floor and you could be close to it and you could blow the whistle and the thing would work fairly reliably. But at my age, it's kind of painful to get down on the floor. So every time the red light turns on, the motor is reversing. And if I tried to tip this over to show you the wheels under there, you got to remember that vibrating switch on top of the Helmholtz resonator, it works off gravity. So you change the angle too much. Let's see if we can do it that much and still make it work. So this is the wheel that's free spinning, that has a ratchet. See, I can't back turn it. So this is the wheel over here that drives all the time. That was another difference between the modern toys, the Masudaya Sonicon Rocket, and this one, which is the Sonar Space Patrol by Yonezawa. The Sonicon toys, like I say, they have the metal Helmholtz unit, but it's also mounted on a bracket where you can click ratchet it into different positions, all the way from being like this to being like this and anywhere in between. And that was how they adjusted the sensitivity of the toy to make sure they could get them built and off the line. Because gravity is going to pull on that little finger that I talked about differently. When it's like this, the little finger's barely going to be touching because gravity's pulling it straight down. The more you pull it this way, the more gravity, the more pressure to be on it, so the more tone it's going to have to see. The more it's going to ignore motor noise and floor noise and all that kind of stuff, but it would take a stronger whistle tone to activate it. So the Sonicon ones by Masudaya Modern Toys was adjustable in that respect. The Golden Sonic, like I say, worked on a little bit different principle. It's still a Helmholtz resonator, but the way they put it over the top of the hole to basically flap in the breeze, because Helmholtz resonators, they breathe. When the correct frequencies in there, air is actually moving in and out of that port, so they put that flap right on top, and that's probably the best way to do it. It was a very big resonator, but it would seem very reliable in that respect. This one would be the least sophisticated in that respect. It was all plastic, which there's nothing really wrong with that, but it wasn't adjustable in its angle or anything like that. And prone to corrosion. The little contact that's in there can corrode, or the one on top of the Helmholtz resonator can corrode. The relay contacts can corrode. All of the brushes that transfer power to these lights and transfer power to the motor, they all corrode. So there's a lot of things that make the toy not necessarily work well over time. But I think that it's a very interesting toy, and this is the one I see the least. So I guess of the sonic controlled toys, this is one of the rarer ones. And like I say, from respect of having everything under a dome, where you can still tell your direction, yet there's nothing to snap off, I really like this design better than the ones that have the antennas sticking out the tops.